All right, welcome to our first quarter statistics practice test video. So we're going to kind of walk through this, make sure that we're all feeling good about what's going to be on our test. So first of all, see that our Idaho State Legislature wants us to estimate the length of time it takes a resident of Idaho to earn a bachelor's degree from a state college or university. A random sample was taken of 265 recent in-state graduates. And again, that's a typo there that will be fixed in the future. All right, let's identify the variable for it. So our variable is the thing that is being measured, or what the response is, right? So when we ask these recent graduates, what they're going to be answering us with is the amount of time that it took them to complete their bachelorate degree. So that's what our variable is our time to complete their degree. Now, part B here is saying, is the variable quantitative or qualitative? So quantitative is something that we can give some kind of numerical value to and count. Qualitative is going to be things like colors, names, just kind of a actual thing as the response. Now they're going to respond to us with a time, so like 2 years, 3 years, 4 years, stuff like that. So that's going to make it quantitative. Think of quantity. And then part C here, they're asking, what is the implied population? So notice that we took a sample of only 265. Now we're not looking at just those 265. We're trying to use those 265 as a example so that we can make a prediction about the entire population. Now the population that we're talking about, since we're looking at only Idaho residents that recently got degrees from in-state colleges, so we're looking at graduates from in-state, at graduates with in-state degrees. Remember, our population is as specific as we're kind of looking at from that sample. So I really want to look at that sample and say, well, what did I pull that random sample from? Because if I just pulled it from students in one town, my population would be students in that town. But since I pulled it from in-state graduates in Idaho, then it's going to be in-state graduates from Idaho or in Idaho. That's going to be my population. All right, so take a look down here for part 2. Now number 2, we're trying to basically determine, is this measurement ratio, interval, or nominal. Now nominal is your kind of least mathy, whereas ratio is the most mathy in that you can do the most kind of math stuff with ratio. You do basically no math stuff with nominal. Let's take a look at the first one here. So the name of a student. Okay, so you have like names like Bob, Joe, stuff like that. So our names, that's going to be a nominal choice. We can't order it. There's no really way that we can kind of organize it. I mean, I guess you could say alphabetically, but that really doesn't matter as far as name-wise goes. So there's really no way for us to kind of numerically order those, right? And then we want to explain our choice. So I'd say, well, it's going to be nominal because there is no numerical way to organize that data. Or the responses. And as long as you can explain kind of why you believe it is, it doesn't have to be word for what you're seeing me put down here. As long as you kind of know, and you're kind of showing me what nominal means by your response, that's good for me, right? So then we got the state ID, your student ID number. So that does have some kind of numerical thing that I can order, right? If this person is number 005 and this person is number 008, I can put those in order numerically. So that's going to be above that nominal letter, that nominal level. But the problem is those ID numbers really don't mean anything. So the fact that I can order them doesn't help, right? I can do it, but it's not beneficial in any way. So it's above nominal, but it's going to stop there when I get to ordinal. It's going to be ordinal because ordering them is essentially meaningless. And that's your kind of cutoff for going above ordinal and into the interval ranges. Well, does the order actually tell us something? Okay. Number 3, we get the cumulative GPA. Okay, so that's going to be a number, right? So it's 0, 1, 2, 3, 4, or something in between those. I'm definitely going to be off of that nominal level. If I get to ordinal, we'll do those. Does the order of that matter? Well, I would typically go 0, then 1, then 2, then 3, then 4. And that order does matter and it does make sense. So I'm up there to the interval level. Now to get to ratio, you have to be able to do a lot of it, a lot with it. Sorry. For ratio, we have to be able to do things like multiply and divide those numbers and have that be meaningful. So I could say, well, a 4 is better than a 3, and that's the same distance better than a 2 is from a 3. So adding and subtracting kind of works, but I can't say that a grade point average of 4 is twice as good as a grade point average of 2. Now numerically that makes sense, but if you think about what that actually means, you're basically saying A's are twice as good as C's, which is not really what that actually means. So we're just going to stop there at the interval level and not make it up to ratio. And then our rationale there is, well, because multiplication and division doesn't work here, and there's not really that true 0. So I kind of focused primarily on the whole multiplication and division not working there. But the whole no true 0 is another way to kind of look at it. Now that you only get a true 0 when you can multiply and divide. So you may say, well, there is a 0 as a grade point average, but that 0 doesn't mean the same thing as a 0 on a kind of standard number scale, right? A 0 on a grade point average could mean you get all 59%, or it could mean you get some 59s and some 48s, things like that. So it's not really that kind of true 0 number as far as causing us to be able to multiply and divide with those values. On D, we're looking at birth dates. This one can throw people a little bit off. So your birth date, while it's not entirely a number answer, we can order it, and that order does make sense, right? You can order that birth date chronologically, right? So that is going to take us above nominal and into at least the ordinal level. Okay. So then our question is, well, can we get up to interval, right? So does addition and subtraction work? Is the difference between those dates can it be consistent and the same? So from day 1 to day 5, so from January 1st to January 5th is going to be this, or let's make it easier, from January 1st to January 2nd is the same as from January 2nd to January 3rd, right? Adding and subtracting does work there, right? But you wouldn't say stuff like, if I was born in January and you were born in February, that my birthday is kind of half yours, right? That's because that's when division doesn't really work there for us. So we can't quite make it up to that ratio level. So we're going to stop there at the interval level. And the reason, again, there's not a true 0. And multiplication and division. Doesn't work. For number E, so we have a number code that represents the class. 1 being a freshman, 2 being sophomores, 3 being juniors, and 4 being seniors. So the number code really doesn't really matter here because you still could order those, but it just kind of is a little bit of a hint for you. So if I go freshman, sophomore, junior, senior, that's definitely nominal at least, but is it ordinal? Can I give that some kind of an order and have it actually be meaningful for me? Well, so I can order it. I can go 1, 2, 3, 4. So that gets me to ordinal, but now is that order meaningful, right? Well, seniors are higher up than juniors, which are higher up than sophomores and then freshmen. So that order does matter, right? And a senior is 1 A above a junior is 1 above a sophomore, and so forth. So that does work there. So addition and subtraction does work, but you would not say things like a senior is twice a sophomore, right? So our multiplication and our division doesn't work, so we don't have that true zero. So again, we're going to stop there at that interval level. Now you could make the argument there that that would be stopping at ordinal, and I would probably accept that argument if you say, well, you can't really add them in, subtract them in that same way because of what they are representing. So you could make that argument there. So I really take either interval or ordinal on that one. Then for F, we have English competence rating. So for this one, we're getting a score of excellent, satisfactory, or unsatisfactory. Okay, so we're definitely at nominal because everything is. If you go up to ordinal, is there some kind of an order to that? Well, yeah, that order of excellent, then satisfactory, then unsatisfactory. So this is kind of better than less good as we kind of go down. But is there really, can I kind of add and subtract here? Is that difference between them meaningful? Well, between excellent and satisfactory, that's kind of a wishy-washy area as far as how much better that is. Same way for satisfactory to unsatisfactory. So we really can't make it up there to that interval level. So we're gonna have to stop there at ordinal. So I would say for that ordinal, I'm going to be stopping there because the difference between the two is not consistent. I also can't do stuff like add or subtract on it. So that's what keeps me from getting up to that interval level. So again, to get to that ordinal, we can order it, but either the order is meaningless or the difference between them once they are in that order, there's no kind of definitive how much better one is than the other. So there's those two things that you kind of have to get in order to get up to that next interval level. All right, so let's take a look at the second page here. So, number 3, we're trying to categorize the style of gathering data. So we're looking for a sampling, experiment, a simulation, or a census. Okay, so remember, a sample is you're going to take a population and then pull out some group from that population. We've gone over some ways to do that. An experiment is when you give 2 different groups, or possibly more, different treatments and look at the results of those different treatments. A simulation is when you're actually trying to, you don't actually do what you're looking at, but you run a simulation, for lack of a better term, that would try and see what would happen if you did this. And then a census is when you take data from the entire population that you were looking at. So let's just keep those in mind as we kind of work through these. So at A, we look at all the apartments in a complex and determine the monthly rent charged for each unit. Okay, so you may be instantly thinking, well, that's going to be a sample because that's only A apartment complexes. But again, your population does not always mean every single thing in the entire world. So how we're kind of defining our population here is really it's the apartments in this one complex because we're looking at all of the A apartments, right? When I see that word, all of the A apartments, that's a really big clue that I'm going to be having a census here. For part B, I want to give one group of students a flu vaccination and compare the number of times these students are sick during the semester with students in a group who did not receive a vaccination, right? So this is classically an experiment. The big thing that I'm seeing there is I have two different groups. It could be more groups, but I'm giving them each a different treatment. One gets a flu shot, one does not. So those are two different things. They're looking at the difference there. That's a pretty classic experiment. For C, I'll select a sample of students and determine the percentage taking statistics this semester. Okay. So big clue there, I said I'm going to be taking a sample. If I was looking at every student in the entire building, that would be a census, but I'm just going to take part of it and kind of and apply that ratio to the whole population. So that's going to be a sample or sampling. For D, I want to use a computer program to show the effects on traffic flow when the timing on a stoplight is changed. So again, clear thing there, I'm using a computer program to do this. I'm not actually going out and changing it and then measuring it. So that's going to be a simulation. All right, let me go down to number 4 here. Try to label these as a statistic or a parameter. So, and whereas statistic comes from a sample, a parameter comes from a population. So that's really what this is asking. First of all, do you know what relates to what? And secondly, do you know what one is a sample and what one is a population? So I'm looking at the average score on the SAT for all U.S. students. Again, I'm clearly defining my population as all U.S. students. And I'm getting it from all of them, so that's going to be a parameter. For part B, the average score on the SAT for Boise State applicants. Okay. So again, we got to look at what the population is. I'm clearly defining my population as Boise State applicants. And I'm testing all of them, so that's going to be a parameter. On C, I'm going to look at the average score on the SAT for a random sample of Idaho students. So the big clear thing there is, hey, it's a random sample, so that's going to be a statistic for me. Right. Take a look at number 5. So I want to identify each of the following samples by naming the sampling technique used. And so it's either a cluster, a convenience, a simple random, a stratified, or a systematic. So going over those one more time here. A cluster, that's when you're going to be breaking things up into different groups, typically by region, and then picking a sample of those different regions, and testing every single thing in that region. For convenience, that's the kind of worst one which you can do as far as good data goes. It's you survey or collect data from whoever is the easiest to get it from. So the people that are nearest you, people that are friends of yours, things like that. Simple random, take your population, you find some way of randomly choosing those in that group, and then taking your data from those ones you randomly chose. Stratified, That's when you're going to be breaking things up into different groups, and then picking a sample from those groups. And then systematic is when we're going to be taking, as you kind of find one place to start randomly, and then go every few from that point on. So all right, I'll take a look at from this point. I'm going to measure every fifth or every sixth or every seventh piece of data that I get from that point on. All right, so let's take a look at which one of these we are seeing. So on A, we want to measure the length of time that every fifth person coming into a bank waits for teller service over a period of 2 days. So I go to the bank, I spend 2 days timing people waiting for service, which is a really exciting, fun job, and I just do it to every fifth person as opposed to every single person. So the fact that it's every fifth person, or it's just kind of that kind of every so often, that's very systematic. Just looking at how it happens, not every person, but every set number between my samples. B, we're going to take a sample of 5 zip codes from the Chicago metropolitan region and sample every elementary school from each of the zip code regions. We want to then determine the number of students enrolled in first grade in each group in these schools selected. So the fact that I'm breaking it up by zip codes, and then I'm just taking some of those zip codes, that's a clear sign that I'm doing a cluster here, right? So I'm going to do a cluster sample. And the whole breaking it up by regions and then randomly picking those regions is your big tell that we're looking at a cluster there. All right, then we want to divide the users of an online service into different age groups and then select a random sample from each age group. Okay. We then ask the members in the sample about the amount of time they are connected on the internet each month. Well, the big thing that I'm seeing there is I'm breaking it up into different age groups and then taking samples from each of those age groups. So that's going to be stratified. Part D, I'm taking a survey of 5 friends regarding their opinion on students on the cafeteria. One sec. Sorry about that. All right. So we are taking a survey of 5 friends regarding their opinion of the student cafeteria. So it's clearly going to be a convenience because we're just looking at, hey, the 5 people that we know. So it's really bad sample size, but it is going to be a convenience. Sampling. All right, and last one here, we're going to pick a random sample of students enrolled at your school and determine the number of dual credits they have accumulated while at Middleton High. So that's clearly going to be a simple random for us. Because, great timing, sorry. Because of that, it being a random pick there. All right, I'm going to do a little pause here and I'll come back for the rest of this. All right, so on to number 6 here. So we have a bookstore that recorded the sales from last month per genre. So we have a 519 for romance, a 732 for murder mystery, 211 for biography, 819 for self-help, 143 for travel, and then 643 for children's books. So the first thing that we're going to be doing here is making a pair 2 chart. Remember that's just a bar graph, but kind of a specialized one where the order does kind of matter here. We want our kind of largest going down towards our smallest. So looking at my spread of numbers here, I got up to 819 and down to 143. So I can't do a whole lot of jumping as far as my graph goes. Again, we don't need super crazy elaborate graphs. We do want them to be titled. This is book sales by genre. And then I need to have my axes labeled as well. So I'll have, it's kind of drawn out like this. Doesn't need to be a huge elaborate graph, but I do want to have it be readable and legible. So this is going to be my genre. And this is going to be my number of books. All right, so I'm not going to have super accuracy here, but I'm going to have, let's do 100, 200, 300, 400, 500, 600, 700, 800, a little bit off there. Oh well, you get the idea. All right, so label those. There's 200, there's 400, there's 600, there's 800. And I should have a little bit more room. I tried to fit this all on as few pages as possible, so I didn't have to print up an extra page for this practice test for us. Anyway, so my largest one I'm gonna have to start off with is going to be I should have a there typo there again. Sorry about that. My self-help I have 819, so I'm going to start off with that one. So self-help. So 819, I'm going to be right up there. And you ideally don't have your bars going through your title, but I'm doing this in pen, and it's a pretty small area, so hopefully you get the idea. Next one that we're going to have is going to be my murder mystery, which is 732, so a little bit lower there. So I'll put M mystery. And then our next one is going to be the 643 for children's. So 600, kind of halfway between that and 500. I'm not looking for super accuracy as far as the bars go, but it should relatively be about the same. Right. This is children. The next one is going to be the 519 for romance. So kind of there-ish. And then after that, we're down to 211 for biography. Right? Yep. So pretty big jump down there. And then our last one is going to be the travel guides, which is down there at about 143. So you get our fair two graph looking kind of like that. Not a huge deal. All right, I'm going to make a circle graph. So to figure out how we're going to divide it up, we kind of need the total number that we have here. So let's pull out a calculator here, and we'll add all of these up. So we have 519 plus 732 plus 211 plus 819 plus 143 plus 643. I think it was about 3,067 total sales. So for our percentages, let's start off with our self-help, which is our largest one. That's going to be 819. We're going to divide that by 3067. So that's going to be about 25% or 27% if we round it. So I'll say for self-help, that's about, we'll say 27% as a point of reference for myself here. Then my next one was 643. Divide that by 3067. We're getting about 21%. Oh, that was not the next one, but well, you still need it. So let's say 21%. I forgot the 732. 732 divided by 3067. That's about 24. We'll go to romance. 519 divided by 3067. We're at about 17%. Biography. 211 divided by 3067. We're at about 7%. And then travel 143 divided by 3067 at about 5%. So if you're trying to make this a lot more accurate and trying to like actually use it as a graph that you would publish or finalize, you really want to find then the angles which those would give you, and probably use a protractor to get a much closer and more accurate angle. But for this, I'm really just kind of looking for, can you give me a general idea of the size of all of those different regions and have them labeled correctly. So this is again book sales by genre. You do want to have those titles, and I'll have I do want to have all my different areas kind of labeled as well. So first one is about 27%, so a little bit more than a quarter. So we'll just do basically a quarter there, and this is going to be my self-help. And then my next one is murder mystery, which is 24. If I add those together, since I kind of rounded both of those up, I should be kind of the other half here. So this would be my murder mystery. And then our next region is 21, so decent amount off of a quarter. So that's going to be our children's book. And then we're out to romance, which is a little bit smaller region than the one we just drew. And then we should have the last two are going to be 7 and 5, so one's a little bit larger than the other one. And again, these are by no means perfect here. So this is bio, this is travel. Those are kind of labels there. So again, is it perfect? No, but the main thing that I'm going to be looking for is, well, our larger ones are the kind of larger ones, and we have our kind of middle-sized ones and our small ones. It looks like I have a rough idea of what I'm doing there. Again, I'm not going to ask you to be pulling out a protractor and drawing these super accurately on a test. All right, let's take a look at number 7. So we have a large set of data here. So this is how we're measuring principal visits per week over a course of 30 weeks. So we have 30 different data points here. So what we want to first do is make a frequency table with 5 classes showing the class boundaries, class midpoints, the frequencies, the relative frequencies, and the cumulative frequencies. So we've told that we want 5 classes. So how we're going to be finding that is we take our largest and our smallest number. So my largest number that I'm seeing here is 32, and my smallest is 3. So if I do that 32 minus 3, so that 29, I want to divide that by 5 for my 5 regions. That gives me a 5.8. So I always want to round up to the nearest whole number, and if you get a whole number here, we'd round up to the next whole number. So if this was 6 even, I would go to 7 for my class boundaries. So, or for my classes. So for my classes, I'm going to start off, have a difference of 6. I'll start off with my smallest one, which is going to be 3. So I'm going to have a class that is 3, starts at 3, and then my next one's going to start 6 above that, which is going to be 9. And then my next one is 6 above that, which is 15. And 6 above that, which is 21. And 6 above that, which is 27. That's going to be my 1, 2, 3, 4, 5 classes. So where those go up to, well, this goes up until this one starts, so my nearest whole number to 9 is going to be the 8, and then going to be a 14, and then going to be a 20, and then going to be a 26, and that's going to be a 32, because our pattern is always going up by 6 on this side, as well as going up by 6 on that side for the limits as well. All right, so now that I have those classes, I want to go through here and figure out my class boundaries. So my boundaries are going to be kind of 0.5 below and a above these. It's always kind of halfway between the upper and the lower bounds. So my boundaries are going to be from 2.5 to 8.5, and then from 8.5 to 14.5, then 14.5 to 20.5, and then 20.5 to 26.5, and 26.5 to 32.5. Now those boundaries, those really tell us kind of what we're going to see as our kind of breakpoints on our histogram. That's kind of their main purpose of us kind of even writing those down. But the class is where the data is actually going to fall into. All right, then we want the midpoints. So midpoints are really just kind of the average or the kind of middle number of all of these of our classes. So if we average the classes 3 plus 5 and 3 plus 8 and divide by 2, so we're going to get it's going to be 5.5, then we're going to get 11.5, then 17.5, then 23.5, and 29.5. This is again just kind of averaging the upper and lower limits of that class. You could do it with the boundaries too. You're going to get the exact same number, but the classes are typically a little bit prettier numbers to be averaging than the boundaries are. All right, so once I have that, I want the frequencies. So you could find the frequencies by first doing the kind of a tally box. If it helps, then you can go ahead and do that. So looking for between 3s and 8s. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Okay. So 10 of those. Now looking between 9s and 14s. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then looking for 15s to 20s. So I see 1, 2, 3, 4, 5, 6. I'm seeing 6 of those. And then I'm looking for between 21 and 26. There's 1, 2. So only 2 there. And then between 27 and 32, there's 1, 2, 3. Just the 3 there. So if we total all of those up, we should be getting 30 total. So I got 10 plus 9 is 19, 25 plus 5, 30. So we got all of them there. So that's a good way to kind of check and make sure that you didn't miss any. Tallies is another good way, but it just takes a little bit more time, but do feel free to do that if you need it. All right, so now we're going to do the relative frequency. So that is really just kind of the decimal ways of showing, or kind of think of it as the percentage of your data that is in each of these different classes. So it's kind of like how we found the percentages for the pie chart up there. We're just going to take our frequency and divide that by our total number, which is going to be 30 in this case. So 10 over 30 is just going to be 0.3 repeating. So I'll just go to 2 decimal places here. And then we're going to have 9 over 30, which is 9 30ths, which is going to be 0.3. So I'll do 0.30. Then we're going to have 6 over 30, which is going to be 0.20. And then we're going to have 2 over 30, which is going to be, that's actually going to be 0.06 repeating. And then we're going to finish off with 3, which is actually going to just be a 0.10. Okay. So again, those are basically just kind of like beginning as percentage. That's the 33%, 30%, 26, and 10% ish again. And then we want our cumulative frequency. This one that you don't see as often, but it's really just kind of where you get that data for your ODrive. So we sum up all the ones that are kind of previous, right? So we start off with 10. That's going to be the same there. and we got to take the next one, which is 9, plus all of the previous, so 9 plus 10 is going to be in that 19. And then we're going to add 6 to that previous one. That gives us 25. Then we're going to add 2 to that next one, and we're going to get 27. And then add 3, and we're going to get 30. So we should always kind of end up with the total number of things in our data set, which is, again, in this case, 30. So there is my frequency table for this chart. I can draw some vertical lines there, make it a little bit more pretty. And again, sorry for the cramped areas to write here, but hopefully it's more about the practice, and if you need more room, I'll have more room on the actual test for you. All right, now we want to draw a frequency histogram for all of this information. All right, so I want to have it be, this is visits per week. It's the title of my histogram here. And I want to kind of break it up here. And then this is the number of visits. Sorry, this is the frequency. My visits at the bottom. All right, so on this one, I'm going to break it up by my class boundaries. You can do a little break here since we're not going to start really at 0, but we're just going to be at 2.5, so not a huge deal. Let's draw that 2.5, and then I have my next break at 8.5. Now all these are going to be evenly spaced. So then I have 14.5. Where these are all just the breaks of the class boundaries that I have here. And then I have 20.5. And my next break is 26.5. My final break there at 32.5. That should give me the 1, 2, 3, 4, 5 different classes. So my first one, we're going up, our frequencies go up to like 10. So I really just need to go up that high. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first one, I go up to that 10. So I'm going to go all the way to 10 for these two here. My next one goes to 9, so I'm just a little bit lower than that. And then I'm up to 6, so 1, 2, 3, 4, 5, 6, right about there. And then we go to 2. And then the last one is going to be at 3. So we get that as our histogram there. Right. Probably have this labeled, so I'll go 2, 4, 6, 8, and 10. All right, so there's my nice little frequency histogram for it. Now I'm not going to ask you for a relative frequency, because really you get the exact same graph. All that really changes from a frequency to a relative frequency is the y-axis scale would then be these decimals as opposed to being the actual numbers there. So if you can do one, you can do the other, and I don't want to waste your time by having you do both on a test. All right, now we're going to be drawing an O-drive for it. So for the O-drive, we're going to take the same information, and we're really going to be kind of going towards our cumulative frequency stuff here. So I draw it out. This is, again, visits per week. I draw out my graph, and we're going to have the same basic class boundaries as we had previously. So we're going to start off here at 2.5, 8.5, 14.5, 20.5, 26.5, 32.5. This is our visits. And so we always start these. We actually need to go to 30 now because we're going for our total for our cumulative. So we'll do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8, 30. 2, 4, 8, 10, 14, 15, 10, 12, 14, 16, 18, 20. Okay, so we get the general idea there. So we're going to always start off this at the lower end of our first boundary, which is 2.5, and starts there at 0. Because really, we have nothing at that 2.5, so it always starts on that x-axis, which feels kind of weird, but that's kind of how these work. After the first one, by 8.5, I have 10. So I have my first dot there at 8.5 and 10. And then by 14, I'm up to 19. And then by 20.5, I'm up to 25. So kind of there. And then by 26, I'm up to 27, so just a little bit higher. And then by 32, I'm up to 30. Again, graph's not perfect, but we should kind of see that general kind of upward slope. Now, an ODrive will never have any kind of negative slopes there. It'll never go back down because it's always that increasing portion. You're going to see those steeper increases where you have these higher frequency charts on your histogram. And you'll have these less steep parts where it is lower on our histogram. All right. And then the last thing here is we will make a stem and leaf plot of that data. So for the stem and leaf plot, like that. I always want my key. So my smallest data set was 3. So it's going to be, I'll do 0, 3 is equal to 3 visits. Right. So then I really have single numbers or ones places up through 30s. So I want 0s, 1s, 2s, and 3s. So counting my number of zeros, I should have, I have 2 3s. Get that in view for you. All right, I have 2 3s. I have a 4. I have a 5. I have 2 6s. I have a 7. I have 3 8s. And 2 9s. If it helps, you can kind of cross those off as you do them. That's fine too. Then for my ones places, I have 2 10s. I have 3 1s. I have a 2. I have a 3. I have 2 5s. I have a 6. And a 7. And then for my 20s, I have 2 20s. I have a 3. I have a 5. I have a 7. And I have an 8. And then I think I have just the 132. Yeah. So 132. So that's going to be my stem and leaf plot. Now when you draw these, my recommendation is a good habit to kind of be in is you want, if you look at it this as kind of columns, you have just the same number of columns for each of these. Or you can see like all of my numbers are in those kind of nice even columns. So it really kind of tells you the further right you go, the more things you have in those different kind of ones, the zeros, the 10s, the 20s, and the 30s. So you get kind of better idea of the kind of different classes there. So really all this is kind of a horizontal histogram where your classes are just defined by the place values, so your tens places there. All right, so let's take a look at the back page here. All right, so number 8. We want to make a time series graph for the price of gold over 8 weeks. So we're going to go ahead and make our graph here. So it's going to be the price. It's going to be the weeks. Now I'm definitely going to want some kind of a jump. I do not want to just go all the way up here to like the 200s, and because my differences are kind of between 289 to 311. So it's a relatively small difference for how big that is. So if I kept my my scale even for each jump, I'd be just barely seeing any kind of changes here across the top. So I do want to kind of do a jump, and I'm going to start, basically let's say start at 285. So I need to have that little jump symbol to show, hey, it's not this low. There is that little bit of a jump so we can see that difference per week a little bit better. And then I want to, I'll probably count by fives. So there's 290, 295, 300, 305, 310, 315. So that's 295, 300, 305, 310, 315. And this is all dollars. All right, and then my weeks, I'll just have 1, 2, 3, 4, 5, 6, 7, 8. We'll keep those as evenly spaced as possible. Again, I'm not going to be here judging your hand sketching of graph skills. I do want to see the labels there, and then our title for our graph is our price of gold. Per week. So it's starting off, and at week 1 we're at 289, so we're going to be right about there. And then week 2 we're at 291, so we're right about there. Again, it's still a very subtle difference, but we can see that a whole lot better when we're this zoomed in. Then we're at 298, so we're going to jump way up to here. And then 305 for week 4. And then 311 for week 5, right about there. And then we have a drop down to 300. So a fairly severe drop there. And then 290, uh-oh. And then we're back up to 316. So then we have a pretty big old spike back up. All right, so again, we then just draw our lines from point to point. Typically draw them actually touching the points, but I'm just kind of leaving those gaps there because in this pen, if I touch them, it's really hard to kind of see where those points are. So you kind of see that over the time, basic little time series graph there. All right, now let's take a look at number 9. So we're given the annual salaries in thousands of dollars for employees in a small company. So this is like $38,500 per year, right? So I want to find the mean, the median, and the mode of the data. So mean is going to be the kind of easy one. I'm going to add all of those up and see what I get. Now I did do this as a practice just to make sure that it all worked out fine. And my calculator here cannot handle me putting in all of these digits with plus signs and doing it all in one big old set. So I'm going to break it up into 2 sets, the top and the bottom, and then just add up those two for my total there. So if we do 38.5 plus 31 plus 29.8 plus 37.4 plus 40.1 plus 35.1 plus 41.5 plus 12.6 plus 39.7 plus 28.4. So that's a 334.1. In the bottom set here, I have a 34.2 plus 38.6 plus 187.4. That's not a typo, that is the actual number. Plus 40.6 plus 39.7 plus 31 plus 29.8 plus 42 plus 30.8 plus 35.5. We get 509.6. So we add those two up, plus 334.1. I get a total of 843.7. All right, so with that, for my mean, my total set that I have here, this is 4 by 5, so I have 20 different people here. So if I divide that by 20, that's going to be my mean, right? So I'm going to get that 42 point, we'll do 19. probably could do 42.2 just to keep it the same, but same idea there. All right, then my median, that's what I kind of want to order these for. So if I want to order these, let's go ahead and just do that here. I'll do it here on the side column. My lowest one that I have is 12.6. And then I believe we go to the 28.4. And then 29.8. And then 29.8. And then I have, I believe, in the low 30s now, so 31 and 31. And then 34.2. 35.1. 35.5. 36s, I have 37. 37.4. I have a 38.5. 38.6. I just saw what I missed, which you probably already saw and are freaking out about. So I'll cover it here in a second. 39.7. And then up into the 40s, so 40.1. 40.6. 41.5. 42. And 187.4. Did I forget the 39.7? I thought I got that one. Yeah, just didn't cross it off. Okay. So then the one that I missed, which is why it's good to cross this off, is I missed that 30.8. So I want to kind of throw it in there. I would like to say that I did that on purpose just to kind of show you how to insert those ones you possibly miss, but I didn't. It's just a happy little accident because that is a pretty common thing to do, which is why it's good to kind of cross those off. So now I have this kind of ordered set, which is going to be a little bit nicer for me to work with, especially when I get to these later parts like the box and whisker plot. My median is going to be my middle number. I have 20 sets here, so if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe halfway between these two is going to be my median. So I just want to average those. So a 35.5 plus 37.4, and I want to divide that by 2. I get 36.45. As my median. And then my mode. Well, I have 2 of those, and I have 2 of those, so I really have a kind of a tie in my mode, and it's fine to have 2 modes. I have 29.8, and I have 31. And as you get like larger data sets and more kind of real world data, that isn't just kind of pretty data they pick for you. You will see stuff that is 2 modes or 3 modes kind of more and more often, especially for stuff like salaries, where if people have these same jobs, they will likely be paid the same amount of money. So then we want part B here. We want the trimmed mean of the data. So it's a 5% trimmed mean. So 5% off of this 20 will be the top one and the bottom one being kind of cut off. So I'll cut off there and there. Now that's a really nice thing for us to look at, because the reason why is, well, this is a really big, a kind of a large outlier level, and this is a huge outlier above it. So if we kind of change to what we're adding up now, I can take that 843.7 number that I got previously, and I'm just going to subtract off the top and the bottom one, as opposed to adding up all of those ones there in the middle to save myself a little bit of time. So that minus 187.4 and minus 12.6. So now I have 643.7, and I have 18 sets of data, so I just want to divide that by 18, and I'm going to get the 35.76. Which is a lot closer to my actual median there, which is what we are kind of after, and it kind of really helps with that mean being not nearly as high as it kind of artificially is, because it's saying that, hey, my average is actually higher than my second highest, which is kind of a not good thing as far as good averages go, which is a really good kind of showcase here for you. All right, so now which of these four averages you calculated is most representative of the average annual salary? Why? So again, you really could say any of them as long as you have a good justification for why you are picking one of them, then that's fine. But like I kind of said, your mean here is probably your worst one, which is also sad because that's typically the one that people use most often for a just generic average, which is good in most cases, but in this case, that huge outlier of 187 really threw off that mean. So if I said, hey, the average person in my company earns $42,190 per year, that sounds pretty good. But literally, all but one person makes less than that average, which is a really kind of a skewed way to kind of say that. But if you're trying to lie to people because you have no morals, then you could be doing that. Now, I would say that our trimmed mean is going to be kind of one of our best. Either our trimmed mean or our median is a kind of a good gauge of that. Both are relatively close, but the trimmed mean kind of takes out those outliers entirely, and our median is kind of a counts for them. So I'm going to say the trimmed mean because it takes out the outliers that were skewing the numbers or the data. All right, so now with the 5-point summary of the data, so that's our low, our first quartile, our median, our third quartile, and then our high. So our low is going to be that 12.6. Quartile 1, I'm going to be kind of halfway between these ones. So I have my kind of bottom 10 points here. So there's 1, 2, 3, 4, 5. So I'm halfway between that 30.8 and 31. So 30.8 plus 31 divided by 2, and I get 30.9. Then my kind of middle point here, my median is going to be that 36.45. Sorry about that. And then my third quartile is going to be halfway up here. So we have 1, 2, 3, 4, 5. So I'm halfway between these two. So 40.1 and 40.6. Divide that by 2, and I get 40.35. And then my high is going to be that 187.4. So really, once we have that data, we can just use that to make our box and whisker plot of it. So I'm going to have a fairly large scale here. I'm just going to draw it kind of over here in this little area. So I want to draw my number line kind of underneath it. I'll start here at 10, it's a little bit lower. 10, 20, 30, 40, 50, 60, 70, 90, 100, 10, 20, 30, 40, 50, 60, 80, 90. So it's 190. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 130, 40, 50, 160, 170. All right. And this is salary. So to draw this out, my lower point, my dot is going to be at 12.6, so way down there. And then my first quartile starts at 30.9, so just barely there. I have a median at 36. And I have an upper at 40. So there's my box. And then I have my whisker up to 187. So this really demonstrates what those outliers do, right? Our box whisker is kind of crazy looking here because I have that extremely long whisker caused primarily by just that one single data point. If I took that off, did my box whisker for just that, I'd have a much more zoomed in and focused thing right about there. Right. All right, and then my inner quartile range is kind of between Q3 and Q1. So if I do that 40.35. And I subtract off my 30.9. I get 9.45. For my inner quartile range there. 1 second. All right, so this last set here, we're trying to find the range of that. So we're looking at bills from couples at restaurants here. So I have a nice little set of only 7, and I'm only going to give you really small numbers for having to do these kinds of calculations for it. So my range is my largest, 46 minus my smallest, which is going to be 21. So it's going to be 25. That's my range. 1 second. All right, so I got to find the sample mean. So for my sample mean here, our formula for that one is your s squared is equal to the sum of x squared minus the sum of x squared over n all over n minus 1. If I plug all of that in, I really want to find my sum of my x's. If I add up all of these ones, I get a total of, I'll write it down here. My sum of my x's is 231. And if I sum up all my x squareds, that gives me 800 or 8,113. That's just square that, square that, square that, square that, square that, square that, and square that, and then add up all of those numbers. Sorry. All right. Sorry, keep getting interrupted here. So putting all these in, I'm going to get the sum of that is 813, or 8,113. I'm going to subtract off the sum there squared, so 231 squared over n, which is 7. I want to divide that whole thing by n minus 1 or 7 minus 1 or 6. Look at that 81.6 repeating. So then my sample variance was, dang it, that's my sample variance that I just found. 81.6. My sample mean, if I average all of those up, I add them all up and I divide, I end up getting a 33. Sorry. Keep getting thrown off by people interrupting me, my bad. So then for my standard deviation, it's really just my sample variance, but the square root of it, right? So I stick the square root of that whole thing. And that's going to be my standard deviation. So I already have that number, so don't do it one more time. Just take the square root of that. You get that 9.04. My standard deviation. Then for the Chebyshev rule, sorry, one more time. All right, so for Chebyshev's rule, we're going to need to, we're looking for 75% of the data to fall within it. So that's going to be 2 standard deviations away from our mean. So our mean is 33. So I want to go above it 18.08 and below it 18.08. So for that, do that 33 minus 18.08. I'll have 14.92. And my top range, if I add that, 33 plus 18.08, maybe 51. So in that interval is going to be 75% of my data. Now that does go above and below my highest and my lowest point. That's because we have such a small set of data here that does have a pretty wide variance. That's kind of why you're seeing that larger number there. Last thing here, keep an eye out for these 3 things. They're not on this practice test, but they are things you do need to know for the actual test. With that, good luck.